today's experiment is going to involve looking at chemical and physical properties of the OH group within different compounds. And what you see on the board, the first compound is an alcohol. We've got this hydroxyl group, the OH group. We also have a type of alcohol which is referred to as phenol compounds. Phenolic compounds will always have an OH group attached to the benzene ring. There is some similarity in some of the reactions that these can participate, and yet there's also some differences there. And then if you also notice at the bottom, we've got an OH group that's connected to a carbonyl group. When you see this combination, we call that a carboxyl group. This is a carboxylic acid. So in terms of the different types of testing that we're going to take a look at, one is an acid test. And for something to be an acid, it needs to have a proton. We call them proton donors. And the proton, there's several protons within all these structures, but the proton that would be the most acidic is the one that's bonded to the oxygen. So the acid test, we use this universal indicator that we will test, not necessarily these compounds, but we'll test different alcohols, we'll test phenol, we'll test carboxylic acids, but they can certainly have different overall structures. This part is not going to change, however, in terms of the carboxyl or the OH to the benzene or OH to an aliphatic carbon. So we'll take a look at the universal indicator, and by dissolving these substances in the reagent, we'll take a look at colors, and what range of colors we see is a good indication of what the pH of that substance is. Not the exact pH, but we can tell whether it's acidic or not. If we have a known acid, and the thing about those indicators is that they contain, I think it's potassium hydroxide, and if you have something that is a strong enough acid, they can react with that potassium hydroxide and change the pH of that solution. And indicators change their color when the pH of the solution changes. So visually, that's how we'd be able to see a difference. We'll take a look at the solubility test. What we're going to use is water and also sodium hydroxide. If we come over and take a look at the functional group, those OH groups or the carboxyl group, anything that can hydrogen bond to water has a greater chance of being water soluble. Usually if you have up to about 4 carbons, water solubility is pretty good, but after that the water solubility goes down greatly. So we'll take a look to see if something is water soluble. And then if that substance is only slightly soluble in water or it's insoluble, then we'll test it also with sodium hydroxide solution. We find that for sodium hydroxide solutions, we can see solubility with phenolic groups and obviously with the carboxylic acid. Chemical tests that we'll also do will be the steric nitrate test, and this will be positive for alcohols and phenolic groups. There is a limitation, however. I think you can. It will be positive if you have up to about 10 carbons. If you have an alcohol that has more than 10 carbons, you may get a negative test. So this is a little bit sensitive as to how many carbons can be contained within the molecule. We'll be looking at a color change there. Chromic acid test. The chromic acid is an oxidizer, so you have to have something that can be oxidized. Out of these different types of substances, what can be oxidized would be alcohols, not phenolic groups, and phenol is a little bit different, but the alcohols that you can oxidize would be primary or secondary. The phenolic group, in order for an alcohol to be oxidized, it has to have a hydrogen attached to the carbon that's bonded to the OH group, and the phenolic group does not have that. And then the iron 3 chloride test, that is specific for phenolic groups. There's a color change there. Chromic acid, color change, formation of a kind of a blue-green precipitate. Here we'll have a color change, and it can be varied. Typically this is more of a yellowish solution. Any color change we see could be indicative of phenolic groups. So what we'll do is we'll have a certain list of compounds that we'll test to see if they're positive or negative based on whether we see precipitates formed or color changes or solubility. then we'll kind of be able to tell what type of functional group we have within that molecule. The first test we're going to do is the universal indicator, which is measuring the acidity or checking for acid acidity characteristics. So what I've done is to prepare a blank of the universal indicator, and you can see that that is a dark green solution. And this is going to serve as our blank because if nothing happens, it should stay that same color. So what I've done is to put about 1 milliliter of the indicator into these separate test tubes, and then what I'm going to do is go back and add a few drops of each. If it is a liquid, add a few drops of the liquid, and then close to about 30 milligrams if it's a solid. We'll stir those well, and then we'll take note of what color we see in that test. So the first one I'm going to do is the isobutyl alcohol. And I'm going to shake that pretty well. Now, if there's no change in the color, we're assuming that the substance we have is such a weak acid that there's no really significant amount of change to cause a change in the color. And alcohols generally have about the same pKa as water. We don't think of water as being acidic, so it shouldn't surprise us that we don't really see a change in that test tube. The next alcohol we're going to use is benzyl alcohol. Add a couple of drops. Shake and see if we see anything happen there. And I don't notice any change in the solution, so as we would expect, most likely an alcohol there. The next substance is benzoic acid. And you can certainly tell there's a change in the color, so it looks fairly red, pinkish red to me. The next compound is salicylic acid. And notice we've had two acids, both of which are changing to roughly the same color there. And then what we have are two unknowns. Our first unknown is a liquid. So I'll add a drop or two of the unknown to our universal solvent. And as you can see, no change there. And then the last unknown we have is a solid. And as you can see, this one changed that pinkish red color. So in terms of identifying the unknown, we can't really tell which of the acids it was. We're assuming this is a carboxylic acid because it has the same color change as the other known acids. But we can't look at this and tell which one is which here. We're assuming that the unknown one is an alcohol because there was no change in terms of the color of the solution for either of those. But we can't really tell, was that the isobutyl alcohol or benzyl alcohol, because all three gave the same color data there.